So today we're looking at sig fig rules, and so we actually have 5 rules that kind of outline all of the kind of numbers in terms of what is significant versus what isn't significant. Now, rule number 1 says that all non-zero numbers are significant. And so what that means is as we're looking at a number, any digit that we have that isn't a zero pretty much always counts. So if we had a number like 332, that means that this has 3 significant figures. Just like if we had a number like 7.63, that means that this is still 3 significant figures because none of those digits are zero. Now, rule number 2 says that captive or trapped zeros are significant. Now, when we say captive or trapped zeros, what we're really saying is numbers that kind of sandwich a zero in. And so some examples would be like 101, which has 3 significant figures, or even if it was something like a decimal point where we said 0.00204, that means that in this case, this 0 is sandwiched in between the 2 and the 4, which means that it is significant, also making this number 3 significant figures. Then rule number 3 is all about our leading zeros, and leading zeros never count. Now, when we say leading zeros, what we're really saying is the numbers that start with decimal places. So anytime we have a number like 0.02, the first 2 zeros in this case are not significant. In this case, only the 2 is. So this only has 1 significant figure. Just like if we had another number like 0.0056, all 3 of the zeros in front here are not significant, only the 5 and the 6 are. And so that means that this is 2 significant figures. Then rule number 4 is all about our trailing zeros. Now for trailing zeros, the rule is a little bit different because trailing zeros are tricky. And so it says trailing zeros only count if there is a decimal place. And so what that means is if we're looking at a number like, I don't know, 100, that means that both of these zeros, because there's no decimal point, don't count. So in this case, it's only the 1. So this number only has 1 significant figure. But if we had a number like 10,000 with a decimal point, that means that all of these numbers, even though they're zeros, are significant. And so in this case, this would have 5 significant figures. Now, what makes rule number 4 so tricky is that this does include kind of weird decimal numbers. So if we had something like 0.450, as soon as we added the decimal point, we know the 4 and the 5 are definitely significant. So those both count. Now zeros after a decimal point and after the non-zero digits, like the 4 and the 5, that means that this 0 also counts. So this means that there's 3 significant figures in this number. Now, if we flipped it and said it was 0.045, because this 0, even with the decimal point, comes before the non-zero digit, that technically counts as a leading zero. So that goes back to rule number 3 as a does not count. So in this case, the 4 and the 5 both count, giving this 2 significant figures. And then finally, rule number 5 is all about exact numbers. And rule number 5 says exact numbers from counting from counting always have an infinite number of sig figs. And so as we're looking at these numbers, that would mean, let's just say you had a bag with 6 apples. That means that this is an infinite number of sig figs. Just like if you were talking about how many, let's just say, centimeters are in a meter, if we said that there's 100 centimeters in 1 meter, this is also something that has an infinite number of sig figs. And so from counting, we can always assume that there's an unlimited number of sig figs.